Hello everybody and welcome back to our challenge to build a workout tracking application. Of course, using the .NET stack. For the front end we'll use Blazor, but I'm not sure that we'll get to the front end today. Good, so yesterday I was unfortunately not able to stream because we had a very nice day here, and after work I went for a workout. So when I came back it was very late and I was not in the mood for coding. Today we prepare for Easter actually in Romania, so it's a bank holiday, so I didn't have to work. But it was still a nice day, so I did my workout earlier today. So right now I'm fresh and able to do a little bit of coding. I can't promise that it will be very long. Probably this one won't be very interesting at all, but hey, that's stuff that we as developers will have to do. So for today, I guess we should continue on where we left off the last time, where we have created some interfaces for our different repositories. So we have an iAthlete repository, we have an iCycling repository, which for now implements the iWorkout repository, where we have, this is a generic repository that will handle only T's that inherit the iWorkout interface, which is fairly nice because we can use actually the same one for all the different workouts that we'll have. And in the cycling repository we'll put some methods, some behavior or properties, I'm not sure, but it's a repository, so probably we will just put behavior here that is specific only for this specific workout. So that is the plan, but for now I don't have any idea of what behavior we might want to put in here. We'll certainly find this sooner or later. Then we have a user repository. Here we have only this update user async method that we will have to implement. Then we have iWalking repository, which is actually, it should implement for now the same behavior as the cycling repository, because well, it's the things that are common actually for all workout types. And then we have this iWorkout repository that we already seen. So we have these interfaces and we'll go to implement those repositories. But before we implement them, I just want to make a short specification, and I already actually tackled this in another of the live streams. I'm not sure exactly in which episode, I guess maybe in episode 2. But this type of application is the perfect example for a scenario where we will actually need both repositories but also services, because repositories will only be responsible for data access, which so if I need to get some data, to update some data, to delete some data, whatever, then this will be handled by the repositories. And then, of course, depending on the type of the repository, we might have some more extensive behavior for getting or updating only certain parts of a certain entity and things like that. But we will also need services, for instance, I don't know, that calculate distances between workouts and how much, I don't know, how many kilometers did I cover during last week or last month or last year. Maybe also generally through all the workouts that actually implement that iDistance workout interface, but maybe also specific for only types of workouts. So I guess we might need to have different type of services here that will probably also use several of the repositories in order to do their job. But that's actually a perfect example for that one. So let's get started. As said, the repositories, the interfaces we define in the core layer, but the implementation should be in one layer that is above it. So in this case, we'll implement this in our infrastructure layer. Now, infrastructure layer might be a little bit misleading. I like to call it that way because, in my opinion, this is actually infrastructure. But in clean architecture, you would have the concept of use cases. So what we have actually here, it's mostly the idea of use cases in clean architecture. So as also showed, I guess, in the first episode where we discussed the architecture that we want to follow, that's actually not totally wrong. So we'll have here for now, let's don't think about services, let's just implement the repository. So we'll have here a folder which will be repositories. Okay. Also, as I always say, don't be shy and hit the comments if you want to say something, if you want to ask something, or well, if you want to come up with an idea to problems that you are facing, or things similar to that. So let's implement the iUser repository first, because it's also the most, or well, the easiest one to implement. It should implement only this method. So let's go then back here, and in the repositories folder we will add new class, user repository, public class. We'll get here, we'll have to inherit the iUser repository. Okay, and let's also implement the interface. It's only one method. Of course, since this is a repository, we'll need a constructor, we'll need a private field, a private read-only, we need a DB context. And this should be in Entity Framework Core. And we also need it here. But actually it's not the DB context that we need. We have our context is track my workout DB context. Track my workout DB context. This is actually what we need. We need our specific DB context. Okay, and then we'll set this. Good. So then the next thing, first we'll need to see how to implement the method. Just let me check some information here, just 1 second. Just let me know if you can see me and if you can hear me well. That would be very important, because I got some notifications from the streaming software that the quality of the stream is actually not the best, I guess. Okay. Well, we can hear you. Thank you very much for confirming. Okay, so here the update user async. So we get here a user object. Once again, this user has address and name plus all the other properties, but there is a service from ASP.NET Core Identity that will handle all the other type of things. Only to the quality is good. Okay, thank you very much for the confirmation. Good. So we'll actually get a name and an address for that. So the name here. Okay, so let's try to do some things here, but right now there is one other thing that is bothering me. Remember that last time, so when we designed our domain model, my idea at least was that I wanted to use like records or classes that behave like value objects in domain-driven design. And this is why I created these record types, but then we see that, okay, we have this value, the system that we use for measurement, but in order to be able to use this with Entity Framework, we need to provide a private constructor, and we also needed to provide an ID for that, which essentially would mean that it would create actually a new table for each distance object that is actually, that belongs to, well, either type of workout. And the same goes for height, same goes for name, the same goes for speed. And I actually I actually don't think I want this to have it this way. If we look in the database once again, just to showcase you the problem that I actually mean. So it would be here, databases, and it would be this one. And you see that if we have here tables, you see that we have here tables for height, name, profile location, profile settings, and weight. These all are tables that I actually don't need. We can have the height values in the athlete itself. So here, so we could have here, for instance, a column that would be called height dot value, height dot measurement system. We don't actually need a table for that, and the same goes for the name. You could just have here, instead of having a separate table for that, because it's only a one-to-one relationship. So in this case, I guess we need to override a little bit the way that Entity Framework Core handles this type of things. So yeah, let's go to this part, and I will create a new folder here, which I will call configurations. And to configure my my models, when I want to use the Fluent API to do that, I usually like to use this concept of configuration classes. And I have a video on the YouTube channel regarding the use of configuration classes in EF Core. But of course, I guess it's a few months since I did that video, and since I wrote the last time a configuration class, and of course I cannot remember everything from the top of my head. So what I will do here is I will just give me a second. I will open a new Visual Studio instance, and I will bring up a project where I actually used those configuration classes, just to take a look at it once again. And I'm not sure what was that project. Was this one? Just give me, I know you can see it on your screen, but until I find it, I just okay, so let me see here. Yes, I have here configurations, I guess. Okay, let's try to do that. So here we would have first a new class, and this would be how should we call it? Athlete configuration. I hope I typed it correctly. Good. So in order to make it a configuration class, it actually has to inherit an interface entity type configuration, and it should specify what type, and in this case it's athlete. Of course, we need to add a using for Microsoft Entity Framework Core, and we need a using for the athlete. Sorry for the background noise. I have a pretty good mic, but sometimes I live on one of the, well, probably main streets of my city, and there's a lot of traffic, and especially now that the weather is better, there are a lot of guys with their motorbikes, and they make a lot of noise, so sorry for that. Good. Now, the implementation for this is actually very, very simple. You just have to implement this configure method on the entity type builder. What I can see here, let's go to the athlete first one. Here, so we have, let's start with the profile location. So the profile location, because it's the same. We don't want to have it in a separate table. This is actually a one-to-one relationship. Each athlete will have one profile location. So yeah, I don't want to have it. So this is type profile location, and its name is location. So in this case, what we could do here is simply say builder owns one, and then we can fluently specify that an athlete, so I use a dot profile location. Wasn't it called profile location? How was it called? What's the name of the class? It's this one. So it should what is the problem here? Because we already have this property. That's strange. Let's see, what's the type of A? It should be because it's the name. Oh, sorry, I guess I'm still a little bit tired. We should use the name of the property, not the type of it. Oh my god, it was so wrong. Sorry for that. Okay, so then we have builder. What's the next one that we want to take a look at? It's the profile settings, and it's called profile settings. So the property is owns one, and this is actually introduced the concept of owned types, and owned types EF Core will put in the same table normally as the parent type. So once again, A from athlete, and it has a profile settings property. It owns one. Then let's go further. What else do we have? We have daytime offset, gender, height, and weight. So these are only also what we need to do. Now builder owns one. A.a height, and same thing, builder dot owns one a dot weight. That should actually do it, I guess. Good. Now, when we have defined the configuration, the next thing to do is we need to also specify in the DB context that we need to use this configuration, and we actually do this in the on model creating. So protected override void on model creating. Okay, so and here I have a builder, and it has apply configuration, and here I can just specify no athlete configuration, and of course I need the using at the top. And what is the problem here? What's the, of course this, oh my god, I guess I'm still tired after today's workout. So sorry for that. And now basically theoretically, if we do the migration, or if we add another migration, I would expect some changes in the table structure. But before we actually do that, we can go here actually for I mean, let's add the configuration for everything. What else do we have in our domain model? We have the athlete, and we have the workout. And the workout, we have also this speed, height once again, and this one not. This is just the foreign key that we actually need. Now, if I think better, no, it's okay. It's okay like that. Let's follow the conventions here. I usually like to use the convention, and only when those conventions are well, not satisfying for me, then I just want to use the configuration. So I'm not the one that just uses by default configurations for everything, or the Fluent API to configure really everything. That's not my type of seeing things. I mean, the conventions in EF Core are there, so let's use them to our advantage, of course. Good. Let's see then. Let's create a configuration for cycling and for walking. But I guess yeah, I guess we have to create a configuration for both of them. So let's go here in the configuration, and here let's add class. Let's call it cycling. Once again, public class cycling configuration, and this should inherit entity type configuration of cycling. And if we add the usings, everything should be right, I guess. Okay, let's just implement the interface. Good. So in this case, it's similar to what we had previously. We configured relationships fluently directly on the builder. Let's take them one by one. So these properties are datetime offset distance. This is actually a type that is this kind of a value object, and I want it directly there. So in this case, builder owns one. Here we specify here this is a cycling owns one. What was the one that I said previously that I want to add here? You know what? Let's go to the properties here. Average speed is of type speed. Okay. Then builder cycling. Okay, date created, date updated, description distance. This is something that, because it's of type distance, it's what we have. Builder.owns one. And see from cycling what we have. The duration. The duration is integer. Okay, so we don't need to do anything here. But elevation gain and elevation loss is of type height. Owns one. Elevation loss. Okay. Then builder dot owns one. Without the dot. What's the next one? ID max speed. I guess it's also of type speed. So builder dot owns one. And C dot. The name here is the string, because then total elevation is also a height. But total elevation is not something that we. Let's go here, because total elevation is not mapped, and actually I don't want to map it, but I don't want to use data annotations. And the reason why I don't want to use data annotations, I don't want to use that data annotations for the purpose of using Entity Framework Core in my domain model. So we have also the total elevation should not be mapped. Let's go back here. That's that on the builder dot. What is the one for has key, has many, property? I guess it's property, which we should use. No, it's cycling dot total elevation, and then I don't remember the exact method for that. So has max length is required, but no, it's not required, but it's actually I don't want to have it mapped. Does any one of you know on top of his or her head what method is used to configure in Fluent using the Fluent API that it should not be mapped? Max length has precision, has value generator, is required. Use identity. Okay. I guess I'll Google it. If core API not because I don't recall it out of the top. I guess it's the ignore, excluding an entity from mapping. It's ignore. I guess it should be with ignore. I thought it would be directly on the property. Yeah, it's with ignore. It should be with ignore. I guess total elevation. Of course, all of these are also generic, so you can simply use this method with the generic version of it, and that should be it. But well, if we're using the Fluent API, I just like to pass in some actions like lambdas. That's cool. So total elevation. Let's go back on the cycling and see what else do we have. But I guess the total elevation, elevation gain, elevation loss, we already have it. Yeah, I guess that should do it. For the configuration of cycling, I guess the same would be for walking. Add new class. Configuration. You know what? Let's just copy this. Okay. First, here it's this one. I guess for the walking, why do I have changes here? I guess okay, remove the row. Good. So for the walking, I guess it's mostly the same things. Although I only have distance here, so that should be easy. So, builder dot swan. Here we have walking, so W distance. Okay, that would cover it, I guess. Oh, for user also we have the name, which is this type of. So in this case, we need to add, in the configuration folder, add class user configuration public class Okay, let's also add the using here and implement the interface. And this one has only the name. Builder owns one. And in this case, we talk about user dot name. Okay, good. Why do you prefer Entity Framework? I find Dapper to be more flexible and not so much configuration as Entity Framework Core. Yeah, but for Dapper you have to write a lot of SQL. And I'm actually not a very big fan of SQL. Although I'm fully aware of what actually Dapper does, and I actually use it in the current project that I'm working right now for work, for my day-to-day work. And the reason is as follows. If I have some quite simple applications, like I think this application would be, then I usually just use Entity Framework Core. But for the production application that I'm building right now, or on which I am working right now, actually, the problem is that, well, first of all, it was a database first approach because the customer wanted it like that. They have a DBA and they create a database, and we as developers should then work with what we have in that database. Of course, we need changes in the database, but those changes need approval and similar stuff like that. But the idea is that also because the way that the database is designed, we have like some of the very core models of that domain, like a payment request, for instance. We need actually to do a lot of calls to the database just to get all the information that we need to actually put in a request when we send it to the front end or when we return it from the payment service. And the problem with that, of course, is that, of course, yeah, we have for each payment request, I guess we have to make at least, I guess, 8 database calls to get all the data that we actually need from there. But imagine that on the front end, for instance, you have at a certain point actually a grid of payment requests that needs approval or similar stuff. Now, the idea is that, of course, if you have in your system, or also based on the filtering that you can do there, for instance, 100 payment requests, that would mean that for each of requests, you would have to make 8 calls to the database using Entity Framework. And of course, this would result in 800 requests to the database, only to get the information that we need to display some requests in the grid. And of course, this actually creates or would create a lot of bad performance of the application, because we know that the Entity Framework Core is not the fastest ORM out there. So we decided that in this case, we will actually go for an approach that we would use Dapper for all the get stuff or for getting the data, and we write actually store procedures that return the data that we need in one single call or in very few calls, however. And then we use Entity Framework Core if we want to perform updates, because Entity Framework Core has a lot of powerful features. Most important of them is the tracking, because when you get an entity from the database, Entity Framework Core adds it to the tracking context. So whenever you change something in that entity that you got from the database, or in the list of entities that you got from the database, all those changes are tracked. And of course, since this concept of payment request is very, very complex, we have services that when we, I don't know, for instance, approve a request, there are different stages or things that needs to happen in that service that set different values for that specific request or part of the request. And in that case, it's actually very useful for us to use Entity Framework Core, because we just get the entity when we start working on it, and then we have a lot of things that happen. All of those things make actually changes to that specific entity, and in the end we just do a save changes async or commit transaction, and that's it. So Entity Framework Core has, of course, its pros, but it also has its cons. The pros are, from my point of view, the tracking context, which is absolutely useful, and well, that's why I use it for writes to the database, like mostly updates. And Dapper is very useful, but it doesn't have that powerful features from Entity Framework Core. So yeah, you actually can execute stored procedures or queries, get the results, bind them to Poco objects, and that might be useful for the getting part. But when you want to update things, well, it's easier to do that using Entity Framework Core. And of course, you could go even one step further. We just use these concepts in a, I would say, very traditional entire monolithic application. So we use Dapper for data retrieval, and we use the Entity Framework Core context for updates. But of course, you could go in a more sophisticated approach when you go for CQRS, and then of course that you would use Dapper in all your queries, and you would use Entity Framework Core in all your commands. And actually, this is an approach that is used by a lot of developers in a lot of very, very big projects, because as said, this type of approach actually gives you or takes the advantages from each ORM and uses them basically to the advantage of the application. So yeah, sorry for this very, very long story, but this was, or hopefully I guess that I managed to explain exactly when I use Dapper, when I use Entity Framework Core. And the reason why I use here Entity Framework Core for this app is because it should be a simple one. If we see that it gets messy or complicated, then I'll surely go for Dapper. But if it gets that complicated that I used to use Dapper here, I'll probably also refactor or re-architecture the entire application to also use CQRS. So yeah, in short, this is the reason why I use right now only Entity Framework Core. I hope this answered your question. Good. Let's get back here. So we have the user configuration, and we say that it owns 1. And I guess that's everything. That profile setting, it just has an ID and time zone and a measurement system. The preferred measurement system, which is okay. You're welcome. I'm glad I was able to explain it clearly enough. Okay. Good. So let's go right now one by one through all these classes, because what we can do here is we don't need the IDs anymore, because these shouldn't be in a separate table. We still will need the private constructor though for Entity Framework Core. So we'll still need that, but at least we can get rid of the ID, which we added merely for things to work with EF Core. But now I guess we managed to improve this a little bit. So for speed, it's exactly the same thing. For weight, it should be exactly the same. Just get rid of the ID. Okay, and then we'll also have here, I guess, for profile settings. So it's the same. We can get rid of the ID. And here we have for the profile location, once again, we can get rid of this ID. Good. Now let's go back to the DB context. So we have here a DB set of users, a DB set of athlete, a DB set of cycling, and a DB set of walking, which is actually okay, what I would expect. And now we should add all the configurations. Builder.type configuration. It would be a new cycling configuration. Then builder.type configuration. Then it would be new user configuration. And then For now, we have builder apply configuration, and here we will have new walking configuration. So that should actually do it, I guess. Good. So what I guess we can do now is we can go and try to add a migration, and this migration, when we update the database, should theoretically change the way that our tables look like right now. So this is what I would expect. So let's go to the package manager console. Let's make it a little bit bigger. Let's choose here the infrastructure project where we have our DB context, add migration, apply configurations, and let's see if everything works out correctly. I mean, theoretically, if everything is correct, we should get a lot of changes to the table, but we have errors here, of course. No suitable constructor was found for entity average speed. The parameter that could not be bound to properties of the entity type. Cannot bind system in. Okay, so average speed. And cycling. What's the problem with the average speed here? Where do we even have this? It's just a speed. In the speed doesn't have a private constructor. Yeah, that's it. Let's just move everything on one line. Okay, and let's run the migration again. Still have an error. Elevation gain. Okay, so height. But we have a. Did I delete? I have a private constructor. What's the problem? Okay, so the entity type elevation gain height is configured as on, but the entity type cycling total elevation height is not. All entity types sharing a CLR type must be configured as owned in the on model creating. Okay, so the problem is, well, that's something that actually it's the first time that I get this error. So the problem is actually here in cycling, in the cycling workout, that we have this speed, which is actually, or what? It's not the speed. It's about the total elevation. We have here heights. We have here property of type height, but this property of type height, or height, sorry, total elevation is actually not mapped. And here Entity Framework Core says all entity types sharing a CLR type must be configured as owned in on model creating. So if we have configured this as owned, then we actually also need to configure this as owned. Okay, I don't like this, of course, but the first workaround that I'll go for is I'll simply configure this as owned also, and I will map it to the table. But the value when we get it should, however, be this one. So that's not nice at all. So here is on the load cycling configuration, and here, instead of ignoring it, have the owns one. But Paul, I guess you're right. So I was a very big fan of Entity Framework Core right at the beginning of my career as a developer, but well, I start to hate it more and more. I have to admit. Okay, so we have done this change right now. Let's see if everything will work out correctly. Okay, So it's the problem of the identity user login. Requires a primary key to be defined. If you intended to use a keyless entity type, call has no key. Okay, but this is not a keyless entity type. But why didn't I have a problem with this earlier? Come on. This user doesn't even have a login property. Identity user login of string. It has this key ID, which by default is string. This is very confusing for me right now because I don't understand why we didn't have this error previously, but we have it now. Because the problem is that we haven't changed actually anything to this identity user. We have just configured this name as an owned entity. Yeah. I don't even have this type, identity user login. Let me see in what we already have in this table. We have here an ASP.NET roles, and we should have here an ASP.NET users. And in ASP.NET users, what do we have here? Have an ID. We have the discriminator, of course, because it's inheritance. So this is what Entity Framework Core added. The discriminator is something that Entity Framework Core added. The name ID, of course, this is something that we have changed. And username, normalized username, email, normalized email, email confirmed, password hash, security stamp, concurrency stamp, phone number confirmed, two-factor enable, lockout, local enable, access failed count. Actually, I don't have here anything like that. Let's try to understand better what exactly happened. Let's try to review this from the beginning. So the entity type identity user login of string. Just let me try something out. Let's go to the DB context and let's comment out the user configuration. Yeah, but then name. Let's go to name and change this, and let's add an public int ID. I just want to see if we revert the changes that we actually did on the user, if we get some, if we are able to run the migration correctly. Okay, it's the same. The entity type identity user login requires a primary key to be defined. So I'm totally clueless why we have this error, because we didn't have it previously, and actually the only things that we did is, you know what, I guess I might know where a problem could be. Let's once again get rid of this ID. Let's go back to our DB context. Let's get this back. But I guess that could be the problem. Let's try to add the migration once again. No, we still have. Okay, no backing field could be found for property cycling total elevation. Okay. Oh, that's so bad. There is no backing field for that because we have only a getter there. So that's so not fun. Okay, get. Let's oh, what's the problem? Okay, so they say that it must declare a body. The problem is that I can have an empty body. That's kind of cool. I didn't know that. Or at least I never used that. So, at least we know that this was the problem why we get the error, because we did apply our configurations, but we actually didn't call the onModel creating and passed in the configurations that we already gave. And then the DB context actually tried to create everything with what we did here, but probably afterwards ASP.NET Core Identity or tries to do some other stuff. So that's why if we call onModel creating and pass in the builder, it will simply add its stuff to the builder that we already configured with what we need. So that was the problem for that one. Let's hope that we solved right now the problem for this one. Because if we have a setter, we should also have a backing field for that. Okay, an operation was scaffolded that may result in loss of data. Okay, of course, because tables will be deleted, things will be changed. So, first of all, we dropped foreign keys for athlete's profile location, location ID, height, and name, which is correct. For profile settings ID and for weight, because we don't have this. Drop table name, profile location, profile settings, drop table weight. We drop the indexes for all of those that were created. Then we drop primary key, of course, yeah, because we don't have a primary key. We drop the columns because we don't have IDs anymore. On all the rename table, new name cycling workouts. We'll just create a new table. Hopefully not. Rename column, name weight ID, table athletes, new name weight measurement system. Oh, what's this all about? Rename column on athletes. New name profile settings preferred measurement system. Okay, because it's this from profile settings. Okay, so I guess that should be okay. Profile settings, time zone. It's because it will actually add columns for all those things. Alter column, total elevation, measurement system, cycling table. Cycling type int, nullable equals true. All C arrive, old type. Okay, I'm not sure exactly why that one. Name, athlete ID, table, int. Okay, so for the cycling, but this should also be a foreign key, I guess. But probably foreign key would be then. But actually those one. So yeah, I said there's a lot of stuff that actually happens. Walking workout. So this is the table for. I guess we didn't perform a migration after we created the workouts. So on walking we have these constraints. We have the foreign key on the athlete, which is correct, and referential action cascade. No, this is not something that I want, because if I delete a walking workout, I don't want this to be cascaded to everything else. So let's click on restrict. That theoretically should throw an error if we violate a constraint, but otherwise it wouldn't try to cascade that. So then perform the action if it would result in a constraint violation, and instead generate an error. Okay. So yeah, this is surely something that I want on restrict. Add foreign key. Let's see, what other foreign keys do we have? I have the foreign key on the cycling workouts. This is the same. I want to have it on restrict. And that's it, I guess. Good. Let's then update database. And hopefully we don't get errors. Now, let's take a look at this. So we have here SQL Server Object Explorer. I don't know what I clicked on. Tables, refresh. So yes, you can see that we have right now less tables. We have the ASP.NET stuff that we need, but then we have only athletes. And if you look at the columns, for athletes, we have here a height measurements system. A column, we have a profile settings preferred measurement system. So it's exactly what I wanted. The value objects are now mapped directly in this table. So that's kind of cool. That's exactly the thing that I wanted to have here. We have an ID which is a primary key, and we have the user ID which is a foreign key, which is correct. This is what I want to have. Let's look at the constraints. I don't see any constraints here. Yeah, so theoretically I should be able to delete an athlete without deleting the user. Then for the height and weight, which is correct. Then we have the cycling workouts. And here we have this primary key. We have a foreign key for athlete, which is cool. Then we have all the stuff, average speed and things like that, including total elevation, which I didn't want, but well, I should get to work. And here I have constraints. Okay. I'm not sure what these constraints are. I guess these are not null constraints. I guess they are okay. And the athlete ID we have here, it is okay. And the walking workout, let's look here. We have an athlete ID, then we have all the things here and constraints. Why is constraints here empty and in cycling it is not? Cycling, what's DF? Athlete, date created. date updated and duration. I guess there are some constraints of this one, but I don't understand what these constraints are. These constraints are regarding the values that you can have on that columns, but I'm not sure exactly what this constraint refers to. Hopefully it's not something with a referential action, but I guess we'll find it out probably later at some point. Good. Well, I guess I'm fine with what we have right now. It's for sure better than what we had previously. I don't want this anymore. Let's make this once again smaller. I don't need this migration anymore. It's already applied. So yeah, I guess that's nice what we have for now. And guys, I would like to take a break right now, a 10 minutes break, and then we'll move on and we'll try to implement the repositories. And that was actually my okay, df stands for default value, I think. Okay, could be. Could definitely be. Yeah, since I don't know, I think you're right. Good. I would like to take a 10 minutes break and then I would like to continue to work on the repositories. And probably that would be a little bit more boring than what we did until now. But hey, well, in programming, you always get to have new challenges, even if you do things that you think that are simple. So yeah, please stay tuned. I will be back in 10 minutes and we'll continue to work on the repositories. Okay guys, I am back I guess. So I just wanted to let you know that before I started today's session, I already recorded a video on ASP.NET Core Service lifetimes that I think it might be one of the best tutorials of ASP.NET Core lifetimes that you'll find online. And I plan to upload it on Sunday afternoon/evening. So stay tuned for that. And I would be glad to receive your feedback on it. Good. This being said, let's try to move on. So I said we have this user repository and we wanted to implement it, this update user async, and we get the updated user. Okay. And then we need to good, so let's do the following. Let's first of all, var user equals context dot users dot first or default async, where user id equals to updated user dot id. So we get the user, and then of course we need to await this, and of course we need to mark this method as async. And then what we want to do is we can set the user dot name equals to updated user dot name, and user dot address equals updated user dot address. Although, you know what we could do here is actually, I said EF Core has some powerful features, and I guess that should actually work. Instead of doing this, we can adjust. We can just simply, we actually don't even need the user here. We just need context.users.update. And here we have the updated user. And then here, wait, context save changes async. Then we return the updated user. Return updated user. Sorry, that's not a method. We just return the user. Because theoretically, it should find the user that has that ID and then do the updates if there are any updates that are outstanding, and that actually would do it. Well, we can move this into a try catch block, and for now we will just rethrow the exception, I guess, but we'll add logging to our system, and that's something that I really want to do. I won't do this today, but we'll come back to it later. And I would also like to do some custom exception handling. So instead of throwing a general exception that comes from Entity Framework, I just want to throw custom exceptions that might also include information about why that operation failed, about the properties of the user, about, I don't know, the service that tried to do this, the method that tried to do this, and things like that. So we will come back later to this, and we'll implement some more advanced exception handling and of course logging, using of course structured logging. That's very, very important. Good. So I guess that should do it for the update user async method. Let's go to another repository. Let's see what would be next. iAthlete repository. Let's try to implement this one. And here we have to make sure that we get a lot of null. We get a lot of parameters with default value null. If they don't want to specify it, then we don't need to update it. So yeah, let's implement this repository. Athlete repository. Let's click add. It should be, of course, public. Athlete repository. It would implement iAthlete repository. Okay. And let's implement the interface, and also let's make this actually a repository. So what we can do here is private read-only check my workout DB context. I was thinking right now that in our repositories we should probably also implement iDisposable. And probably if you're using entity framework in DB context, you know that it knows how to dispose itself. But we'll see later, probably not in this episode, that when we want to use repositories in Blazor server, and on the front end we have Blazor server, things are a little bit different. And if you want actually to take a sneak peek into what I mean by that, there is a video here on this CodeWrinkles channel. It's called something like implementing repositories in Blazor server the right way. And that in that video I actually explain exactly what is the difference, and you'll see also why we need to dispose them. But yeah, let's think about that a little bit later, probably just a few minutes later. Okay, let me go here. Sorry once again for all the noise. Yeah, I kind of hate motorbikes because they make lots of noise by night, and I cannot do a proper live coding session because of them. So of course I have an error here, and then context equals context. That should do it. Let's go and think about the iDisposable right now. I guess let's create because I don't want to add iDisposable to everyone. So let's add a new interface. Sorry, it's an interface, and it's I track my workout repository. And that interface, what it does, actually it doesn't do anything, but it says that it should implement iDisposable. And just like that, it means that also in the user repository we would need to implement iDisposable. No, because we have to make, of course, or our but that's exactly the same. If I need to add the, but don't I have this I have a workout repository that is specific for all the workouts as an interface, but I guess I'll still keep this this interface that I have created, this track TMW repository, and I will make all the repositories implement this. ITM. The reason why I would keep it is because I would put here also behavior that is specific for all repositories in the in this application. So yeah, let's also here ITMW repository. Okay, this is the exact repository. User repository, the same ITMW repository. Then working repository, it should also implement ITMW repository. And the workout repository, actually on the working repository I actually won't have this because I'll put this on the workout repository. Okay, so it implements I guess it should be like that. ITMW repository and then the where. Okay, that should be fine, I guess. So let me then go back to the already implemented repositories. It should be the user repository, and of course they say I will have to implement the interface. So in the implementation, but okay, I want to have this one at the end of all my other repository methods. So let's take a look, and it would be here. And in the dispose, I would just context dispose. And I will not use the async method in this case. I will just use this one. Okay, so in the athlete repository, it's exactly the same thing. Let's go here, and probably if I click on implement interface, hopefully it would put it at the end. No, it didn't. It takes them alphabetically, I guess. So let's take it out from here and move it to the end. And once again, what we'll do in this dispose is context dispose. Okay, so that would be it. Now here we have a lot of things to implement actually. So creation is actually very simple. We won't add any validation right now. If we want to add validation, once again, we'll add validation. This is also a concept that I like and I always use from domain-driven design, even if the project is not really 100% domain-driven design, is the concept of invariants, which actually means things that would put my object, my class, into an invalid state. And when I create a new object, and when I update a new object, I would have to check for invariants. So this means that I would add all the validation logic that I need for a valid athlete here in this athlete class, not in the repository. And this would actually give me a warranty that if I get here a user that is not null, actually, it means that the user, this athlete, would also be in a correct state. So this is why I don't have to do any type of validation here. The only validation that I have to check is if it is null, if they pass me null. So let's say here if athlete equals null. For now, I'll throw new argument exception, I guess. Argument null exception. Let's just give here a basic message. Once again, we'll implement a more extensive and custom exception handling mechanism with our custom exceptions. But for now, we just write here a message, for instance, that and that should be it. If this is not the case, then context.athletes.add, and that should actually be it. I guess I have a typo here. And then await context.save changes async. Okay. Of course, I have to mark this as an async method, and I should return the athlete, so I'll just return the created athlete. Okay, and I'll also put these three lines into a try catch block. Actually, I want to put all of them, because if I throw the exception here, I want to catch it and log it here. So yeah, we could even have several try catch blocks, but I guess it doesn't really make sense to create several try catch blocks right now. Good, and if I get an exception, I just rethrow it for now. And I guess that that would be it. Then delete async. Here, let's create a try catch block from the start. So I'm not sure here. Wait, context dot athletes dot. I guess it's remove. But I need the athlete, of course, first. Of course, I need it, so I need to get it. For user, it's not user, it's an athlete. That equals context dot athletes dot first or default, and here where athlete ID equals athlete ID. Where is here is a typo. Okay, good. So, and then I want to remove the athlete. Of course, I have also to mark this as async. Good, and what is the problem with you? Of course, I need to await. I need to await also this one. Come on, what's wrong with me? I guess I have to go to sleep. What is the problem right now? Have the context. It does not contain a definition for get a waiter. How so? Context athletes. Do I have a typo here? Oh my god, yes. First or default async. Thank you very much. But still, it doesn't want. dbset add does not contain a definition for first or default async and not accessible. But why? Oh my god. Okay. Okay. I guess I have to I have to stop. Good. So then here await athletes, remove athlete. What is the problem? Not good definition for get awaiter once again. Remove is not an async, and that's why we shouldn't await it. It just adds it to the entity that needs to be removed, and then await context dot save changes async. But before we actually do that, I guess we need to check some things here. If this is null, then we should throw an exception. If athlete, of course we need the brackets, if athlete equals null, then we want to throw new argument exception. Let's use string interpolation for the message here. No athlete with ID and then ID. What is the problem here? Probably a typo. Good, so we throw if we don't have an athlete, and then we can just remove and save changes, and then if this goes wrong, we just for now throw this method. Okay, we still have to return the athlete if it was created, so return athlete. Actually, we returned the athlete that was just removed. That's the whole idea. Good. Let's go then for the next one. Update basic info async. Okay, here we have this gender, URI, a profile photo, date time, and so on. Let's split this up. URI, height, okay, something like that. So in this case, what do we need to do? Let's create a try catch block from the beginning. So first we need to get the athlete based on the athlete ID. Or it equals context.athletes.first or default async. And we look for an athlete with the athlete ID equals to the athlete ID that we have previously. Now here, similarly to what we did before, if the athlete is null, actually we can just simply rethrow this. We can just copy this here. Okay, we throw the argument exception. And then, okay. So then what we would have to do, just 1 second, I want to make sure that you can still see me, but I guess you can still see and hear me. Good. So then the next step is we want to do different type of updates. Now the gender cannot be null, because it is an enum, it can't be null, it is a value object. So doesn't matter if it is the old gender, if it is the new one, we just will set it. Athlete.gender equals gender. Now for the profile photo, what is the problem? Int does not contain a definition for gender. What is the problem here? So gender is an enum. I don't have this property on athlete. Let me go. First of all, we should also make this async. And if we are here, let's go to the athlete. It's gender. It's an enum. Okay. So what is the problem then? Get this gender and we want to assign it here. So int does not contain definition for gender and no accessible extension methods. Gender accessing the first argument of type int could be found. You're missing using. That's strange. It's not a property of athlete ID. Oh my god. I really have to go to sleep, I guess. But it's also not a property of this one. Yeah, correct. It's a property of athlete. But then let me. Okay, and then what's the problem right now? Of course we have to await, and now it should be okay. Yeah, I guess that's a sign that I guess we'll have to stop this. Good. Then for the profile photo, we just have to check it. If it is not null, then we will set it. If not, we will not set it. So we'll do here a simple if. So if profile photo not equals null, then at lead dot profile photo URL equals profile photo. Okay, and I guess it's the same that we have to check for datetime offset. Well, if it is the default. Okay, so here the if is a little bit different. If datetime of that, I don't know, does this have a method something like is default? No, it doesn't. If in that case is default. It doesn't work like that. Okay, yeah, of course we have to specify the, but it's still it's not is because we don't check for the type. It's like that. So so actually if it's not equal to the default value, then we'll set it. Dot date of birth equals DOB. Then what do we have? We have a height, and the height, if it is null, yeah, I guess it can be null if height not equals null. In that case, we'll set it. Okay, and the same goes for weight. If weight not equals null, then we'll set it, but it's not like this, it's lowercase. What's the problem actually? The problem is a typo, of course. So it weight not equals null, then athlete weight equals weight. Good. So in this case, we have done all the updates that we want. So we can context.athletes.update. and here I provide the updated athlete, and then wait context.save changes async, and of course then we have to return the updated athlete, so we will just return that. Good. So at least right now we don't have any errors, so we don't have errors anymore. And yeah, if somewhere here we have an exception, probably the only exception that could be thrown, except the one that we throw ourselves, is the save changes async, and if it throws, we catch it, and right now we just rethrow it. Okay guys, so I guess that that's it for today. It seems that I'm too tired and I'm missing a lot of very simple stuff, like for instance that I tried here and I didn't understand why don't I have a gender when I was in fact using the athlete ID here instead of the athlete, so which of course is not very nice. So this being said, thank you very much for watching. I'm not sure if all of you are from Romania, but for those of you who are from Romania, I wish you a happy Easter, because it's Easter time, and I'm not sure exactly when I'll do the next live stream due to the period of Easter and things like that. But you can expect the video on ASP.NET Core Service Lifetimes on Sunday. If you didn't subscribe, then please just subscribe to get notifications and to know whenever I go online the next time. Once again, thank you very much for watching. Until the next time, I wish you the very best and take care of you. Bye.